Here's one example. Here is a table from a journal article reporting the significance levels of variables after running this analysis. ANOVA stands for Analysis of Variance. And what the researcher is looking at is the variance in tuition at different community colleges. And the different types of community colleges are rural, urban, basically on an urban-rural scale, suburban. And so they're looking at different tuition levels in district, in state, and out of state of community colleges that are rural, urban, suburban, and I think there may have been one more. Suburban. And this is how they reported the analysis of variance. It's not so critical that you understand this terminology yet, or this terminology, or this terminology yet, but an ANOVA uses what we call an F statistic, and it's the F statistic on which the statistical significance level is reported. Okay, so in the same way that the Pearson's R is a statistic for which we report significance levels with a p-value, so that's like Pearson's R. We report p-values, and these are the p-values, so this significance thing is a p-value for the F statistic, looking at analysis of variance. And we're going to talk more about analysis of variance later. Okay, so this is how they report significance. 0.104. Well, is that greater than or less than 0.05? It's greater than, much more greater than. So they've reported that p-value, but it is not significant. Whereas, and that's for in-district tuition. So what they're saying with the significance is that it's not significant, that it doesn't matter if the college is rural, urban, or suburban. These colleges do not vary on in-district tuition. But they do vary significantly on in-state tuition and out-of-state tuition. And so that's what these significant levels are telling us. This p-value is 0.001, and it is definitely less than 0.05. The researchers could have reported this in terms of 3 asterisks. That's just notation, just standard notation. Same thing with the out-of-state tuition. And so what you see on the right-hand side here is how the researchers have, in the text, reported out their results. This is right from the text of the journal article. Researchers reported that they found no differences between and among colleges in regard to full-time in-district tuition, regardless of locale. That's how in the text they wrote up this result. They also said significant differences were indicated for in-state and out-of-state full-time tuition based on locale. So that's what they said for this result and this result. Let's look at another example. Example number 2, relationship between control variables, tutoring, and student success. So in this research, the authors performed a t-test, an analysis of variance using the F statistic, and also chi-square. We'll learn about all of these types of analyses in a moment, once we learn about significance. And if you look down their columns, see how they're reporting. They're reporting, this stands for the T for t-test. The F stands for the F statistic, or the analysis of variance. The asterisks report are the level of significance, the p-value, are the asterisks. And down here in the chart, you can see they've made a note. 1 asterisk. Well, in their case, 1 asterisk is standing for less than 0.01, and 2 asterisks is standing for 0.001. And that's actually not convention. The 0.001 would have been 3 asterisks, and the 0.01 should have been 2 asterisks, because standard convention is 1 asterisk is 0.05. Regardless, they provided the note so that you understand what the asterisks are for. And if you look down this column, you see that every statistic they ran was significant, statistically significant. And what they're looking at, they have demographics here. These are probably their control variables. And their tutoring and student success. Their student success measure is their dependent variable. And tutoring was probably their primary independent variable that they were interested in. The rest of these were control variables. So you look down this column, successful course completion. So student success was measured as GPA, and it was measured as successful course completion. It was measured as persistence to spring. So they actually had 3 dependent variables to measure student success. Really intriguing research. So if you look down this column, you'll see which statistics they found to be statistically significant, and where their statistic was not statistically significant, they didn't have any asterisks there. Not significant. Out of all the analyses they ran, only 3 of them were not significant. Everything else was statistically significant. And so here's the way the authors wrote this up in their text. T-tests or ANOVAs were used. As Table 2 indicates, tutoring and almost all control variables were statistically significant in their association with the student success indicators. So that's how the researchers wrote up their statistical significance and what it looks like in terms of convention. Just because something is statistically significant does not necessarily mean it's an important relationship. I mean, just because you can generalize a finding to the population doesn't mean it's substantively significant. So in order to report substantive significance, researchers now report effect size too, which answers that magnitude question that we looked at. And Voigt argues that it's important to report effect size. And we're going to learn how you do that, how you run those analyses in SPSS, what that means. Let's look at some examples. For just because it's statistically significant doesn't mean it's important. Sometimes non-significant findings are important too. For one example of non-significant findings, Fleming and Garcia found few significant differences between African Americans and whites in correlations of SAT scores and college grades. Well, that's a pretty important finding, that there were no significant differences there. I mean, that can tell you something too, even if your findings are not significant. Comparing college student evaluations of professors, researchers found no statistically significant male-female differences. It's another example of a finding that was not statistically significant that you can make meaning out of. What's important about statistics, because you can have the software package do anything that you want. It's important that you have good thinking behind what what you are doing, what your analysis is. Do you even need to use inferential statistics? If you do not have a probability sample, meaning if your sample is not made up of randomly selected units of analysis, you don't need to use inferential statistics. But if you do, if you have a randomly selected sample, how do you figure out which statistics you can use? Depends on your level of measurement of your variables. Once you run the statistics and you find that your results are statistically significant, what does that mean? What if they're not? Is that an interesting finding in and of itself? And just because they're statistically significant doesn't mean it's an important relationship. You have to look at what is the magnitude of the relationship. How big is it? They could be statistically significant but extremely weak. And you see that when we talk about the correlation coefficient, the Pearson's R. When we talk about the Pearson's R, and we see a relationship that has a Pearson's R of a 0.2, it can still be statistically significant. But this tells us it's an extremely weak relationship. And it tells us, if we want to look at a magnitude of relationship, if we were to square the R, we would get 0.04 if I square that 0.2. And so that's another way to tell us, well, I'm going to just keep on going, that only 4% of the variance in one variable is accounted for by the other variable. That's what that 4 tells us. We're going to learn a little bit more about that, how to calculate magnitudes and effect size. Finally, are non-significant findings meaningful? They could be. You just have to think about it in relation to your research problem. We'll be moving on to hypothesis testing next.